Let's take a look at number 8 here in section 10.3. They ask us to use the limit comparison test for this series, n equal 20 to infinity. They call this a sub n, and here's the a sub n, the terms of the term of the sequence that we're adding up from 20 to infinity. So we're going to prove using limit comparison whether this is convergent or divergent. So the question is, what are we going to compare it to? Well, for large n, remember what we look at. We look at the highest degree in the numerator and the denominator. Up top, it's obviously 4n squared for a sub n. What do we have in the bottom? Well, I'm not going to multiply this all out. You can, but clearly the highest degree term will be n cubed, right? N times n, when I fold this out, will be n squared times the n will be n cubed. So I have n cubed plus something n squared plus something n and so on, but I don't care about those lower degree terms. So it's approximately equal to this, which simplifies down, right, to 4 over n. So I'm going to look at the corresponding series. I'll call it b sub n, right, this one. And we know if I just take that 4 out, this is divergent because it's a harmonic series or a p series with p equal 1. So this is divergent. And so I'm going to compare my a sub n's to the b sub n's, right? And then the limit comparison test, remember, works this way. We take the limit of the a sub n's to the b sub n's as n goes to infinity. So there's my a sub n's, there's my b sub n's. Divided by 4 over n is the same as multiplying by n over 4. Distribute here, I get 4n cubed plus 17n. And here I'll just get 4n times all this stuff. Well, what's the limit as n goes to infinity of this? Well, you can use L'Hopital's rule 3 times, expanding all this out and everything. Or if you just realize the highest degree term is 4n cubed, and what's the highest degree term going to be here? 4n cubed again, right? Because I'll have n times n is n squared times the 4n. So basically for large values of n, it looks exactly like this, and the limit of that, of course, is going to be equal to 1. Now, what's that mean? Well, limit comparison, if this limit is finite and positive, meaning greater than 0, then both corresponding series converge or both corresponding series diverge. In this case, since we know this series we're comparing to, the b sub n's, if you will, that series is divergent by limit comparison. Our series that we were looking at, the a sub n1, also diverges. Okay, I hope this is helpful. Very nice use of limit comparison.